Today's goal is to be able to create a scatter plot and line of fit. Scatter plots can show trends in data. A correlation is a relationship between data sets. If we plot x against y, and if we see a shape looking like this, it means there's a positive correlation, or in other words, as x increases, so does y. If we see the data kind of going downward, that is a negative correlation. As x increases, y decreases. Or if we see the data scattered all about, then there's really no correlation. The points show no pattern. So what do we need to do? When data show a positive or negative correlation, you can model the trend by using a line of fit. Keep in mind what we're doing here is simply on paper, and it's our best line of fit. However, later we'll use Desmos to find the line of best fit. What we'll do first is we'll make a scatter plot of the data and decide whether the data can be modeled by a line, whether there is a correlation or not. We want to draw a line that appears to fit the data closely. There should be approximately as many points above the line as below it, and we'll use a straight edge. Then we'll write an equation using 2 points on the line. The 2 points do not have to represent actual data, but they must lie on the line of fit. Note, like I said, we'll use Desmos later. But for today, we have a table here, problem 1, that shows the value of a car in thousands of dollars after X years. We'll make a scatter plot and draw the best line and find the slope and be able to write that equation. So here we have our data, and the age of the car is given, and that's our X value. So you might want to label your axes. So here, down here, our X is really age in years. And then our Y is value in thousands of dollars. It's your job to figure out how to scale your graph, and the age goes up by just 1. It goes from 0 or 1 to 8. And so luckily there are 8 boxes here, so we can make each one just 1 unit. So this is going to be, there's not much space, but 1, 2, 3, 4, 5, 6, 7, and 8. The value goes up to $24,000 as the highest. Again, that's divisible by 8, so that's nice. So we can make each one go up by $3,000. Now that we have it scaled, it's just time to plot X and Y. So we have 1, 24, 2, 21, 3, 19. So just estimate 19 is a little bit above the 18. 4, 18. 5, 15. 6, 12. 7, 8, and 8, 7. Now that we have it plotted, we are going to draw the line that appears to fit the data closely. We will use a straight edge, and it's important that we try to get approximately the same number of data points above and below the line. So just use another sheet of paper and give it your best try. It doesn't have to run through all the data points, but it would be helpful, and so I do recommend probably for this exercise just make it run through some of the data points. I'm going to extend the line a little bit here, positive and negative, but especially closer to the y-axis. And let's extend that y-axis up. Oops. Because we need to find the y-intercept. Looks like the y-intercept would hit approximately 3 more units up, so probably around 27, that's what I would say. And then let's find the slope. So pick any 2 points that you can see clearly hit the grid. So probably best would be this point right here and this point right here. So the slope. You want to draw some sort of staircase, and we're moving from left to right. Now this could have gone over here and then down. Either way, it's equivalent. But what I'm looking for right here is the change in y. That change in y is going down, and then the change in x is positive, or going from left to right in the positive direction. So be careful here. It's not every box is actually 3. So we're going down from 24 to 12. You can count it in threes. We're going down 3, 6, we're going down 3, 6, 9, and 12. Yeah, we're going from 24 to 12. So this is really negative 12. That's the change in y. Now the x, we're going over by 3's as well. So 3, 6, 9, 12, 15. Oops, the year, actually we're going by singles, by 1 year. So this is actually going 1, 2, 3, 4, 5, plus 5. So it says select 2 points and find the slope of the line. So slope is the change in the y over the change in the x. You might want to write out that little bitty formula. Those triangles are delta symbols that mean change. We found the change in the y was going down negative 12, and the change in the x was going up plus 5. If you'd like, you can make that into a decimal. Not required, but we have 12 over 5 is 2.4. So we found the slope is negative 2.4. Next, we need to write the equation in the form y equals mx plus b. So remember, in this equation, the m is the slope, and the b is the y-intercept. That's why I drew this line a little bit above here, and I'm going to estimate that it's 3 more units up, so that would be 27 for the y-intercept. So just fill in those values. Now we have y equals negative 2.4 x plus 27. Interpret the slope and the y-intercept. The slope, that is a negative value. It's going down, so it really can be written as negative 2.4 to 1, and that would mean y is our money, so our value, so the value is going down $2.4 thousand per 1 year. So let's write something like that. So I wrote the value is decreasing by $2.4 thousand per year. That was the slope. Now let's interpret the y-intercept. What does it mean if it started up here at $27,000? That's where time is 0. That would be the original cost of the car. Or the original value. And that makes sense, $27,000. Use your equation to predict the value of the car after 10 years. I think I'll use some function notation on this one. So our function was y equals, but we're going to call it f of x equals negative 2.4x plus 27. Now we're going to find that function at 10. That means we're plugging in 10 for x. To multiply 2.4 times 10, just move that decimal point over. Remember, it's negative, so it's negative 24 plus positive 27. Putting those together gives you 3. But that's not your answer, because really it's $3,000. So not worth that much money. Should have just written this as with 3 zeros after it. But $3,000 is the value after 10 years.